The spiral machine is used to produce spirals for use in spiral screens. Monofilament made from various plastics of various widths or with flat profiles are used as source material. For example, PET, PPS, PA, etc. In the following, monofilaments are also described as thread and spiral wire. The spiral machine essentially consists of two spindles that function independently of one another. Monofilament spirals with round and rectangular cross-sections can thus be manufactured, spirals wound simultaneously to the left and to the right. When using round monofilament, right and left-hand spirals can be produced on each spindle. For technical reasons, when using monofilament with a rectangular cross-section, only right-hand spirals can be produced on the right side, and left-hand spirals on the left side. The explanations of the terms below are listed in the order of the monofilament or spiral flow. That means from bottom to top. All monofilaments are processed on a K335 spool. The maximum winding on the coil is between 7 kg and 10 kg, according to the shape and diameter of the wire. The coil drive depends on the wire tension sensor and ensures a uniform tension of the spiral wire, regardless of whether the monofilament is still on the coil. In other words, the drive also functions as a brake. The winding plate guides the spiral wire as it is pulled off of the coil via the various guides and rollers up to the center of the spindle during the winding process. Depending on the type of spiral wire used, round or flat, different winding plates are used. From the center feed-through guide, the spiral wire continues up to the winding head. Round winding plate is driven via a drive belt during the winding process and is meant for flat monofilament. Segment winding plate is meant for round monofilament. It is locked during the winding process. The drive belt is not mounted. Via the thread tension sensor, the control system constantly adjusts the current thread tension with the parameter values specified in the controls, and readjusts accordingly via the coil drive and with flat wire also via the winding plate drive. Depending on the manufactured spiral size, either the left 10 Newton sensor or the right 60 Newton sensor is used. The spiral wire enters the winding head from below, where it is wound around a spiral mandrel mounted in an intake. The process speed is set by the drive. Depending on the profile and/or diameter of the spiral wire, rotations of up to 3,200 revolutions per minute are possible with flat monofilament, and up to 5,000 revolutions per minute for round monofilament. Depending on the type of spiral wire used, dimensions and material, and the predetermined spiral dimensions, spiral mandrels with various dimensions can be used. The spiral wire wound around the mandrel through the winding head heads up to the mandrel as a spiral with each rotation. The length of the mandrel passes through the heater to just below the pull-off roller at the top of the machine. All mandrels included with this machine have uniform intakes, making them easily interchangeable. A control panel is located on every machine side, which is only used to perform the machine's basic functions. The spiral passing through the mandrel is fixed in the heater, meaning that the spirals are heated in order to prevent them from twisting or springing back onto the mandrel when leaving it. Ceramic infrared heating elements are located in the two-section heater housing. The control system monitors the temperature in the heater via two thermocouples. The control system adjusts the temperature in the heater where needed. The heater is preheated before the process begins. Once the target temperature has been reached, the winding process can begin. The temperature must first be set in the process parameters of the respective program. This is described in Chapter 2.4. The heater, which is still in neutral position, is then pneumatically opened, pneumatically pivoted to the spiral mandrel, and closed again in that position. The heater now surrounds the spiral mandrel with the spiral feeding in from below during the winding process. The heater's motion sequence is controlled manually with the buttons on top of the machine. The cooling unit is located above in two-section housing, integrated into the two-part heater housing. The spirals moving up out of the heater are cooled back down in the cooling in order to compress them, and to allow for spirals to be manufactured from thick monofilament. Cooling occurs via the cooling unit installed on the back side of the machine. The driven pull-off roller is located above the upper end of the winding mandrel. Depending on process speed and preset pull-off value, the roller pulls the spiral up from the spiral mandrel, and from there the spiral moves down into the spiral can via a downward-sloping guiding track, slide. The spiral can also be wound 1 to 2 times around the pull-off roller in order to increase the tensile force. Cans are placed behind the spiral machine to collect the spirals as they exit the machine. The size of the plastic piping cans is selected to fit the amount of spirals coming off of a 7 or 10 kilogram coil. The tops of the cans are fitted with slots into which the end of the spirals is hooked. In order to connect a spiral sieve, the spirals are processed directly from the cans. Many spiral machines can be monitored via one control center, server, and programmed via one central touch panel. A few buttons for starting the spindle and operating the heater, separate for each spindle, are located on the machine itself. All remaining functions, in particular the input and monitoring of parameter values, are controlled exclusively via the central touch screen. The corresponding station, machine with 2 spindles, is chosen in the Start menu. All necessary parameters for this machine, depending on the spiral type to be processed, can now be read, separately for each spindle, fixed or changed. All important machine functions, along with the current parameter values, are displayed on the clearly laid out control menu screens in the respective menu areas. Turn on the machine with the main switch located on the side of the control box. Then the machine's internal operating system will boot up. The heater can now also be turned on with a push button in order to use the setup time on the machine for heating. The target temperature must first be set in the process parameters of the respective program. More information you can find in Chapter 2.4. Each machine is displayed with a button on the central touch panel's Start menu. Once the desired machine has been selected, that machine's current actual values are displayed for both spindles. From the window with the actual values, the selection window for the selected machine can be reached via the Process button. The choice between round spiral and flat spiral can be made here. In the next step, the rotation or winding direction for the respective spiral is selected. Then you can return to the window with the actual values by pressing the Back button. From the window with the actual values, you can reach the parameter window of the selected machine by pressing the Select button. Here you can either enter the individual process parameters according to specifications, or make any necessary adjustments during the current process. From the window with the actual values, you can access the parameter window of the selected machine by pressing the Edit button. After selecting a free program slot, in this example it is program slot number 5, an empty parameter window is going to be displayed. Tapping the top yellow data field opens a keyboard window that allows you to enter a program name. For example, it can consist of the monofilament sizes and the name of its material. Then the parameter values for the new program can be entered and confirmed. This is done by pressing a numeric keypad, which appears by tapping the corresponding data field. Creating or modifying a program is only possible when the machine is stopped. According to the planned process, round or flat spirals, different procedures are required when setting up and programming. The respective sequences are described in the following steps. The initial situation is the following. Machine is switched off. No coil is mounted. Switch on the machine at the main switch. The machine control will now start up automatically. Now turn on the heater. Please note that for this machine, a program with the corresponding heating parameters must be selected, as it is shown in 2.4. Prepare the following tools: hook spanner, Allen key 6 mm long, control box key, scissors, hand gloves, calipers. Place spiral cans behind the machine and select size according to the expected spiral quantity. This procedure is only necessary for changing the spiral size or monofilament. A long 3 mm and 6 mm Allen key is required for changing the spiral mandrel. Loose the screws on the front cover of the winding head with the 6 mm Allen key. The housing half can now be removed at the front and set aside. The mandrel is then rotated such that 2 magnets are visible on the left side between the narrow side of the mandrel and the housing. The angle should be around 45 degrees. Now it's time to make a color marking. The color marking ensures the correct positioning of the mandrel and helps to avoid problems during the working process. Now remove the 2 clamping screws located on the hub of the winding head opposite one another for the mandrel intake with a 3 mm Allen key. After the previous step, you can pull up the intake. After loosening the clamping screws with the 3 mm Allen key, the mandrel can be removed from the intake. To insert the new mandrel, follow the reverse order of this process. Then screw both clamping screws down again, and pay attention that the mandrel is positioned perfectly in the intake. When inserting into the intake, the narrow side of the mandrel must again face the marking. Then insert the mandrel intake, with the newly mounted mandrel back into the winding head, and tighten the screws on the winding head firmly again. The two covers of the winding head can now be remounted. It should be noted that the alignment of the marking for the mandrel is the same as the position for disassembly. Make sure that the screws are tightened. If the mandrel is twisted, it will be in the wrong position when closing the heater, which will prevent it from closing correctly. Now check the correct adjustment of the intake via a test run. If the winding head is too high, the spiral wire will rub against the magnets during the winding process and tear. If it is too low, the winding point on the mandrel will be incorrect, and the desired dimension of the spiral cannot be reached. If it becomes necessary to correct the height, the intake must again be removed from the winding head, and the height must be readjusted on the adjusting screw. The spiral mandrel is typically only adjusted when a new mandrel is used for the first time, or when a different spiral size is required. The spiral mandrel essentially consists of two parts, the mandrel itself and the head. The mandrel can be moved up and down in the head, and is locked into position with two threaded pins, using an Allen screw. From the side view, the mandrel can be divided into three areas: base, conic area, guiding area. The height adjustability allows spiral wire, which feeds onto the mandrel during the winding process, to hit a specific location on the mandrel during the winding process, the ideal winding point. If the point at which the spiral wire meets the mandrel is too high or too low on the mandrel, the resulting spiral will have irregularities, or the thread could snap. For round profiles, the mandrel is fixed in the head such that approximately 8 to 10 mm of the mandrel base is visible as a feed area. The exact dimensions of the feed area have to be verified or determined via a test run. The winding point here is on the bottom end of the feeding area, just above the head. For flat profiles, the mandrel is fixed in the head such that the transition from the mandrel base and the conical area is exactly flush with the upper edges of the head. There is thus no feed area. However, the following also applies to flat profiles. The exact setting dimensions have to be verified or determined via a test run. Open the shutter and swing the thread tension sensor backward. Loosen the screw on winding plate with an Allen key 6 mm and remove the winding plate. Now place this on the provided depositing arm. Lock the spindle and coil by pulling out the black safety mandrel and pushing in the slider. Turn the coil until it clicks into place. Now the small LED has gone out and the coil is locked. Open the clamping disc with the hook wrench and remove the coil. Now a new coil can be inserted. Make sure to pay attention to the takeoff direction of the coil. When inserting the coil, it is very important that it sits on the spindle as far as it will go. If this is not the case, the coil can loosen during the winding process, and thread breakage occurs. Tighten the clamp screw firmly with the hook spanner. Take the winding plate from the depositing arm and put it back on the spindle. Make sure that the screw is tightened again. Fold the thread tension sensor forward again and fix it with the fastener. Now all you have to do is release the lock by pulling out the black safety mandrel and sliding the slider back into its original position. When the small LED lights again, the lock is unlocked and the coil has been replaced successfully. Use scissors to cut the knot of the thread on the coil. Regardless of whether left or right spirals are being produced, the thread is generally pulled off of the coil to the left. Wrap the thread on the first rocker roller once, then thread the thread through the guide roller to the second rocker roller. This is also wrapped once. Next, it goes to the first roll of the wrapping, around which the thread is also wound around once. Subsequently, the thread is guided over the second, third and fourth roll of the winding table. Now you have to thread the thread through the ceramic eyelet and pull the thread further up, through the eyelet of the thread tension sensor, further up into the hollow axle of the winding head. Push the thread through until it looks out of the winding head. Tie the thread with the spiral mandrel. Make sure you pay attention to the desired winding direction. After wrapping, rotate the coil so that the thread is under tension, and then place the thread onto the appropriate thread tension sensor. Which thread tension sensor is used depends on the dimension of the monofilament and the size of the spiral. Now check again the thread course, if everything is fine. After the final inspection, the machine door can be closed and locked by means of a switch cabinet key. Only after correct locking of the door, the process start can take place. The machine itself is now ready for the winding process. Now the manufacturing parameters according to the spiral type and size via central touchscreen are set on the controls. First unscrew the clamp screw and open the lock. Then swivel the drive motor forwards and pull the drive belt off. Then swing the drive motor backwards. Loosen the winding plate from the spindle with SW5 Allen key. Remove it and place it on the depositing arm. Lock the spindle and coil by pulling out the black safety mandrel and pushing in the slider. Turn the spool until it clicks into place. Now the small LED has gone out and the coil is locked. Open the clamping disc with the hook wrench and remove the coil. Now the new coil can be used. Make sure to pay attention to the takeoff direction of the coil. In the case of the flat variant, the following applies. The left side of the machine is only for left-hand spirals, with the direction of withdrawal to the right, and the right-hand side of the machine is only for right-hand spirals, with the withdrawal direction to the left. When inserting the spool, it is very important that it sits on the spindle as far as it will go. If this is not the case, the coil can loosen during the winding process, and thread breakage occurs. Tighten the clamping disc firmly with a hook spanner. Take the winding plate from the depositing arm and put it back on the spindle. Make sure that the screw is tightened again. Move the drive motor forward again and hook the timing belt into the pulleys. Then push the motor backwards to build up tension and close the clamping screw. Now the shutter is still closed. Now all you have to do is release the lock by pulling out the black safety mandrel and sliding the slider back into its original position. When the small LED lights again, the lock is unlocked and the coil has been replaced successfully. Use scissors to cut the knot of the thread on the coil. Pass the thread past the first guide pin and through the second pin. Now pull the thread through the guide hole of the winding plate to the top. The further course goes through the first guide roller on the winding plate to the passage opening in the hub of the plate. It continues through the guide eye below the thread tension sensor in the hollow axis of the winding head. Now the thread is pushed through until it protrudes at the top of the winding head. Then the thread is knotted with the spiral mandrel. After knotting, rotate the coil back so that the thread is under tension and press the protruding thread under the second roll of the wrapping plate. Then place the thread on the respective thread tension sensor. Which thread tension sensor is used depends on the dimension of the monofilament and the size of the spiral. After the final inspection, the machine door can be closed and locked by means of a switch cabinet key. Only after correct locking of the door, the process start can take place. The machine itself is now ready for the winding process. Now the manufacturing parameters, according to the spiral type and size via central touchscreen, are set on the controls. Selecting the machine. In this example, it is machine 10. Press the button Station 10. Current actual values for both spindles of the selected machine are on display now. Now press on the Process button. That is how you reach the pre-selection menu of the machine. Spiral type can be chosen here, according to machine preparation, by pressing the middle button. The rotation direction left or right can be set with the left and right buttons for the corresponding spindle. The values shown in the number fields are only for informational purposes. They cannot be changed. Use the button Back to return to the actual values display. Press the Edit button to reach the input window for the process parameters. Depending on the type and size of the spiral, default values including cooling, heater temperature, above or below, spindle rotational speed, brake and pull-off can be selected here. Inputs and changes can be made via the numeric keypad, which appears after typing on the corresponding display field. Entered values are accepted via the Enter button. Once the heater has reached the target value, see Window Actual Value, the spindle can be started by pressing the green Start button on the top of the machine. When the spindle starts running, the tied spiral wire must be secured with 2 fingers during the first rotation to prevent it from winding onto the mandrel. During the startup phase, the wound spirals, as needed according to spiral type, must be lightly pushed up onto the mandrel by hand, to avoid tangling and a resulting tear in the thread. Then the spiral must move upward on the mandrel by itself. If this is not the case, then the process parameter is not correct. Open the heater while the spiral is in the upper position. Now swing the heater to the mandrel using the push buttons. As soon as the wound spiral reaches the top end of the mandrel, the heater is closed by pressing the corresponding button, and the spiral is placed in the downward-sloping guiding track of the machine. The dimensions of the spirals must be regularly checked during the first few minutes of the winding process. If needed, the process parameters must be corrected. The spirals, which are wound until the desired dimensions are reached, are not suitable for sieve production. Once the desired size has been reached, the spirals are guided to the provided cans. At this point, measurements in half-hour intervals are sufficient. 1-hour intervals if the machine is warmed up. The winding process runs automatically. If a disturbance occurs, for example a thread tear, or the coil is empty, the machine will shut off automatically. The red light on the spiral guiding arm will illuminate and an acoustic signal can be activated. When turning the machine off, the heater is automatically opened and then turned into inactive position. Definition of spiral dimensions. L equals length of spiral, T equals thickness of spiral. Size L too large. Thread tension too low. Increase process parameter break. For PET in intervals of 0.5 newtons, for PPS in intervals of 0.2 to 0.3 newtons. Size L too small. Thread tension too high. Reduce process parameter break. For PET in intervals of 0.5 newtons, for PPS in intervals of 0.2 to 0.3 newtons. Size T too large. Heater temperature too high. Reduce process parameter temperature above or below in intervals of 5 degrees centigrade. Size T too small. Heater temperature too low. Increase process parameter temperature above or below in intervals of 5 degrees centigrade. Spiral shape irregularities. Mandrel not properly positioned, too high or too low. Readjust mandrel. Thread tension too low. Increase process parameter break. Temperature too high. Adjust properly process parameter temperature above or below. One small and one large calibrating weight with approximately 5,000 grams or 500 grams and a hook at the top are needed for calibrating the thread tension sensors. The 500 gram weight is for calibrating the 10 Newton sensors, and the 5,000 gram weight is for the 60 Newton sensors. The Spiralmachine's selection window can be found above the service button located at the bottom of the touchscreen. Select the desired machine by pressing the corresponding button. This will open a window in which all further steps are processed as described below. The exact weight of the small and large calibration weights must first be determined and entered into the data fields. The values labeled thread tension 1 refer to the 10 Newton sensor, and thread tension 2 refers to the 60 Newton sensor. For unloaded sensors, the 0 values, not equal to 0, are initially determined in the controls. By pressing the button 0 point, the value displayed in the corresponding data fields is transferred to the left side of the display. The values for the other sensors are now recorded sequentially in the same way. In the white data field on the right side of the 10 Newton sensor currently loaded with the calibration weight, its weight value is now displayed. This value does not correspond with the weight of the calibrating weight in grams. By pressing the Calibrate button, the value displayed on the right is transferred to the blue data field on the left. Now the weight can be replaced by the large test weight, and the spiral wire can be guided outside over the roller of the 60 Newton sensor. Tie the spiral thread to the spiral mandrel. Then wind the wire on the outermost deflection roller of the winding plate back to the coil. Then pull the wire over the deflection roller mounted under the machine table top. Now cut the wire about 50 cm below the upper deflection roller and knot the end into a loop. First, the 10 Newton sensor is calibrated with the smaller weight. The weight is also hung in the prepared knot in the spiral wire. The weight must not swing during calibration, because if it does, no single value will be available as a basis. The spiral wire must now rest on the outside of the roll of the respective thread tension sensor. First, the corresponding machine, station, is selected in the controls in the service window. In the window Service Station 10, the target values and the actual values of both sensors are displayed accordingly on the left and on the right for each spindle. In the white data field on the right side of the 10 Newton sensor currently loaded with the calibration weight, its weight value is now displayed. This value does not correspond with the weight of the calibrating weight in grams. By pressing the Calibrate button, the value displayed on the right is transferred to the blue data field on the left. Now the weight can be replaced by the large test weight, and the spiral wire can be guided outside over the roller of the 60 Newton sensor. The second sensor is now calibrated in the same manner. In order to ensure error-free operation, the following cleaning work has to be done at least weekly. Clean, if necessary, the coil clamping rings in the coil housing, the winding plate, the thread guide rollers, and the interior of the machine. To clean the winding head, open the winding head and pull off the front and rear covers. Then clean the thread guide channels with acetone. The acetone has to be injected with a syringe into the thread outlet. Keep acetone about 1 hour in the winding head before blowing out. Keep a cleaning cloth pressed against the head on the bottom end. Ensure that no acetone drops on the sensors. In order to ensure error-free operation and machine safety, a few maintenance operations must be performed regularly. Check the drive belts and belt tension, coil clamping rings in the coil housing, winding plate, and thread guide rollers. Check the coolant level in the storage tank, and if needed, top up with water biocide mixture.